Hi there, in today's video we're going to be continuing trigonometry, but we're going to be dealing with bearings, okay? So we've explored bearings before during high school, whether it be maybe in first year or second year, and the important thing to know is when we talk about bearings, it is given to us in a three-figure digit, okay? So for example, 52 degrees, if it was written as a bearing, would be 052 degrees, okay? Obviously anything over 100 is three digits anyway, but it's always important to know that we must write bearings as three digits. However, there is some very important rules when it comes to dealing with bearings, okay? So the first important rule is that when we are talking about a bearing, we always measure from north, okay? So north's our line that we use, and we measure round going from north to east, down to south, round to west, and then back up to north. We always start at north, okay? And the second rule tells us that we go clockwise, hence why we go to east after north, okay? We go around in a clockwise fashion. And just a reminder, all bearings must have three digits. Now, when we talk about bearings, it's very common for a question to tell us a bearing of a place from another place, and explicitly they say from as opposed to, okay? So they don't sometimes say the farm is on a bearing to the town, they can sometimes say the farm is on a bearing of 075 degrees from the town, okay? So what that would mean is you would start where the town is, work out where your north line is, work out what 75 degrees is, and then if you headed along that 75-degree line, you would then end up at the farm. Okay, so the key word there is from, they say that quite often. Okay, we're going to look at a couple of examples today where we're going to have to solve using trigonometry a question. However, bearings will help us set up the question. Okay, and these can be quite common exam questions too. So we spoke about these policies here, these notes. So for example, we're in 12.3 in our notes now. So bearings are used to describe the direction in which to travel to get from one place to another. They're measured from north in a clockwise direction, we spoke about that. And it can be from any angle from 0 up to 360 degrees, but it must be written as three figures. Okay, we've covered that too. So here's a question. Now I've actually changed your first question in the notes, so you might need to, well, you will need to rewrite that first question. If you want to do that on the back page of that note, then that is fine. Okay, so from D, the bearing of F is 023 degrees. Okay, and from D, the bearing of E is 082 degrees. Okay, the question we've got, and we can see our triangle diagram, is how far apart E and F are. Okay, so the first thing I'm going to have to do is on my diagram, I'm going to have to put in my bearings. Okay, so I'm going to highlight the keyword from D. So that means I'm starting at D, but using its north line. I'm going to measure around 23 degrees, and that should take me to where F is. Okay, so if I do that, that means that I'm starting at D on the north line. I'm going round. I hit where the line would take me to F, and I know that is 23 degrees in there. Okay, it then tells me from, and again I'll highlight this in a different colour, that from D, the bearing of E is 82 degrees. So that means if I start at D and travel around clockwise 82 degrees, I'll end up on a pathway to E. So we're going to have to write again from D now. Again, my diagram might not be the cleanest here. Okay, so what I'm going to do is I'm just going to extend my line a bit so that I can show you that if I travel round from D along to E, along to the line that takes me to E, that would be a distance of a bearing, sorry, of 82 degrees. So what we're going to do is we want to work out how far E and F are. And what we've been given is we've been given these two angles here, and that's going to help us work out what the actual angle inside here is, okay, just inside the triangle. That's what I want to find out, okay. So if I just can label this, so I'm going to label my angle EDF, okay, that's the angle D down this bottom corner. From D, from the north line all the way around to E, I know the angle was 82 degrees. The bit I don't need is the 23 degrees, so I'm going to take that off. Therefore, the actual angle inside my triangle is going to be 82, take away 23, which is 59 degrees. Okay. At this point, it's probably a good idea to just give another sketch of your triangle. Now I'm going to re-edit this because that's not a good attempt straight away. So just a quick sketch to show what we have found. So I know that it is 59 degrees in there. That is my point D. That is F up there, and E is there. My sides, okay, 8 kilometers from D to E, and it is 22 kilometers from D to F, okay? And now we can answer it like a normal trig question, okay? So the first thing we do is we label our sides. So D is going to be opposite angle D, E is opposite angle E, and F is opposite angle F, okay? And the angle at D is 59 degrees, okay? So now we're in a position like we were last time round where we're having to work out at the distance from E to F is D for us. What rule would I be using? Okay, so the first rule I always tell you to work out is to use the cosine rule. So we're going to check if that would work if we have all the information. We're going to write it using D, E's and F's. So D squared would be E squared plus F squared minus 2EF cos of the angle D. So to work out D squared, I need to know E squared. Well, E is going to be 22, so I can work that out. F is 8, I can work that out. Okay, I know E and F there, and I know my angle at D, so this one will help me. This one is going to be the one I'm going to use, rather than the sine rule here. So I'm just going to put my numbers in now. E squared is 22 squared, plus 8 squared, minus, again, use your brackets when you use the cosine rule, 2 times E, that is 22, times F, which is 8, times by cos of 59 degrees. Okay, and if you put all that into your calculator, what you should end up with is 366.7065. Continued. Okay, so remember this is D squared. If I want D, it means I take the square root of 366.7065. Okay, I'll finish this over here. D would be 19.1495, which rounded to 2 decimal places would be 19.15, and my units were kilometers. Okay, so there's an example that bearings can help us work out the angle inside the triangle that we needed, and we can then work out the missing length that we were asked once we had that angle that we found there. Okay, so that's where bearings can come into play when dealing with trigonometry. We're going to look at the second question. The second question is not changed from your notes. Okay, so you should have it looking like this. So again, I'm going to highlight the key facts. So it says from G, okay, the bearing of A is 52 degrees. Okay, so I'm going to draw that in first of all. Okay, so from G, if I travelled around 52 degrees from the north line, it would take me to the line that would take me to A, so that would be 52 degrees in there. It then says that from A, okay, so we're now starting at a different point, so from A, the bearing of E is 216 degrees. So that means if I started at A, so I'm going to start from the north line at A, travelled round till I hit the line that takes me to E, that would be a distance of 216 degrees. So, and our question is asking us how far apart are G and E. So what we need to do is work out how I can use the information I now have in my diagram to help me work out a missing angle, okay? And the chances are it's going to try and be this angle in here due to the fact that I've already got a lot of information surrounding this angle over here. So the angle at A. So let's see if I can use my lines to help me, okay? Well, what I'm actually going to do is I'm actually going to extend this line from G to A along a bit, and you'll see why, okay? So what I've done, I've extended the straight line. Now, using the laws of angles, so I've actually created an F angle here, where 52 degrees underneath my north line would also be 52 degrees under this north line from here to here. Okay, so using the fact that this is now a straight line, I can work out the angle in here. Okay, so I'm going to label this just a different colour so you can see what I'm talking about. So the angle that I'm going to call the blue angle, that's going to be 180 because it's a straight line minus 52, and that would give me 128 degrees. So 128 degrees goes inside there. So now I know that from here to here is 128. I know that bearing that I initially started with was 216 degrees all the way from the north around to A. So to work out the gap, I'm going to take both of them off of 360. So the angle that I need to work out is A, so it's going to be EAG. That's going to be 360 minus 216 minus 128. Okay, and I get the answer 16 degrees. Okay, so that one was a bit trickier there. What it means is that my triangle now, if I draw it semi-sensibly, okay, unlike the last one, 16 degrees will be inside there. That's what I have managed to find using laws of angles that I've known from the previous years. Okay, 16 would be down there, 20 would be down there, and I'm asked to find the length from G to E. Okay, I'm going to label my triangle now like we do with trigonometry. So once I've got my bearing sorted to help me find an angle, can I use trigonometry at this point here? So G is going to be, sorry, E is going to be opposite angle E, A is going to be opposite angle A, that's the one I'm actually going to find, and small g is going to be opposite angle G there. So again, this is finding a side, so we've got the sine rule or the cosine rule. Again, we check the cosine rule first to see do we have the correct information. So it's going to be a squared. Now it's normally b squared plus c squared, but for us it's going to be a squared plus g squared minus, I don't need my brackets in at this stage, my apologies, I'll take that out, minus 2 lots of eg cos of the angle at A. And I know E, lowercase e, that's my length, that's 20, so I can work out E squared. I know my length of G, which is 16, so I can label that too, I know what that is. And I know my angle at A, so this is going to be the rule I need to use again. I've got all the information I need. So that's going to be 20 squared plus 16 squared minus, put this in brackets, 2 times E, which is 2 times 20, times by 16, times by cos of the angle 16. Okay, put that into your calculator. What you should get is 40.79 ... We know the protocol by now. And where's my cursor? Where my cursors went? Haywire, there we are. So remember that's a squared, so I'm going to carry this on over here. So A would be the square root of 40.79 continued. We get the answer 6.3869, and if we round that, we got 6.39 kilometers. So there's 2 questions today, and it just so happened that they both seem to end up using the same rule. That won't always be the case. You'll sometimes need to use the sine rule. It might be finding an angle eventually. Okay, so you use the alternative sine and cosine rules. But there's 2 examples where we had to use bearings in order to work out the angles inside the triangle to help us then work out what the question was asking us to do. Okay, so the main point about bearings is always make sure you're remembering that it is from a certain point normally. Okay, so read the question really carefully. It tells you where you're starting from and then going to, and remember your laws of angles to help you work out the missing angle inside the triangles you require. Okay, thank you for listening.